Welcome back to our RPG tutorial series. In this episode we are going to improve the enemy chase mode, because our enemy should probably do a better job of chasing us by now. And we are not stopping there. We will also add some new sprites for the collectible mushroom, the campfire and the respawn ghost, to give the project a few more visual highlights. So this episode is all about smoother gameplay and some nice visual upgrades. Let's get started. First, I didn't really like how the chase mode worked in the last version. It felt a bit unstable and was prone to bugs. One major issue was the way the enemy's speed increased the further it was from the player. If the chase range was large enough, it became almost impossible to escape. The enemy just kept speeding up like a heat-seeking missile. So in this version, we'll change that. Just like in the idle mode, we'll give the enemy a constant chase speed. That should make the behavior more predictable. Once again, we use the positions of the player and the enemy to define a direction vector, but this time we multiply it by our speed and assign it to velocity. Using velocity instead of manually changing position lets Godot handle movement properly. It works seamlessly with move and slide, which means collisions, sliding and physics interactions are handled automatically. If we move the position manually, we would bypass all of that and potentially break collision behavior. And don't forget, we also have to call the function. That's a classic mistake and I've done it more than once. Now, with this local variable, we'll set a max distance between the enemy and the player. This way the enemy doesn't walk right on top of us. It just looks better and feels more natural during the chase. Of course, we also need a proper chase animation. And yeah, this one is going to be a little tricky. But the good news is, we already have the sprites ready for all 4 directions. We'll need animations for idle side, idle front and idle back. If you haven't created them yet, just take a moment to set them up and assign the correct sprites. We'll use idle side as usual for both left and right. We already have our chase vector here, and we can use its x and y values to determine the direction. Just like we did with the idle walk, we'll check which way the enemy is moving, and then play the correct animation. The logic itself is actually quite simple. First, we compare the x and y values of our vector. This tells us whether the enemy is moving more horizontally or more vertically. Based on that, we decide which direction to prioritize. If the movement is mostly vertical, we then check whether it's going up or down. We do that by checking if the y value is greater than 0. And for horizontal movement, we do the same. We check whether the enemy is moving left or right. With these simple comparisons, we can reliably determine the exact movement direction. here's a nice little trick. We'll make sure the animation only plays if it's not already playing. That prevents it from restarting every frame, which could cause visual glitches or a choppy look. Oops! Found a small bug in the code. Let's fix that quickly. And finally, we'll make sure that idle and chase animations don't run at the same time. And that's it. The player chase function and the chase animation are now complete and working just like we wanted. Alright, let's take care of the enemy death animation. We've already got the sprites ready to go, we just need to hook them into the logic. We'll place the death animation right here in this function. This is the spot where we're already checking if the enemy's health has dropped to 0. That makes it the perfect place to handle the enemy's death. Everything we need is already here. We just add the animation trigger. And of course we still need a few checks. First, we'll create a new variable to track the enemy's alive status. This lets us control when actions like movement or damage are allowed. We'll add this variable into all the functions that need it. Before we move on, we should extend the final frame of the animation. This gives the animation a clean ending and avoids it jumping back too quickly or restarting unexpectedly. Next, we need to make sure the final frame of the animation doesn't instantly reset. To do that, we'll create a timer and connect it to the death sequence. We'll also add the timer signal to the signal group we've been using. That keeps everything organized and easy to manage, just like before. Let's also make the timer a bit longer so the animation has enough time to play completely before anything resets. Alright, let's test what we've got. The animation works, but I don't like how the enemy slides away after dying. That doesn't look right. So let's fix that by setting the movement speed to 0. But not here. We'll do it right before the animation starts. That way, the enemy stops completely before dying. One last test. Perfect. Everything works just as we imagined. Now it's time to handle the player's death. We'll follow a similar approach to the enemy's death logic and use this already existing function to trigger the animation. But in this case, we still need to create the animation first. No worries, the sprites are already prepared and ready to go. Just like before, we need to make sure that our death logic doesn't get accidentally overwritten by other functions. The strategy is the same as we've used in earlier steps. Simple, clear and reliable. So just follow along with what I'm doing here, or if you feel confident enough, go ahead and try it on your own. And of course, if you come up with a cleaner or smarter solution, drop it in the comments. I love learning from you just as much as you, hopefully, learn from me. That's what makes this journey fun, growing together. We'll also need a timer, so that after the animation plays, the player gets removed from the scene. Let's quickly extend the timer duration, run a test, and see what we've got. Looks pretty good already. But I want to take it one step further. Let's add the animation for the new ghost character that appears when the player dies. That adds a nice story touch and some atmosphere. If you want to use the same sprites, you can download them from my itch.io page. The full project will also be available for download, with all the sprites already integrated. Let's bring that ghost to life. For our new sprite, we'll start by creating a new character body 2D. We'll save it in our scenes folder and name it Spirit. Then we'll add a collision shape 2D and an animated sprite 2D. Make sure both of these are children of the Spirit node, so everything stays properly connected. By the way, the campfire and mushroom sprites are also included in the downloadable package, so if you've grabbed the project from my itch.io page, you already have everything you need. Let's do the exact same setup for our campfire and our mushroom, since we'll be using them in the same way later on. So, 3 times the same routine. Character body 2D, collision shape 2D, animated sprite 2D, and save each as its own scene. Let's get the animation set up for the Spirit. If you downloaded the sprite from my itch.io page, make sure to copy the image files into the correct folder so they show up here in the Sprite Frames editor. Once they're in place, you'll be able to select and assign them easily. Let's bring these assets to life. Now it's time to set up the collision shapes for our new sprites. We don't want the player or the enemies to just walk straight through the campfire or the mushroom, right? So we'll add proper collision shape 2D nodes and make sure they block movement as expected. As for the spirit, well, that one's more of a ghostly presence, so we can skip the collision shape here. No need to block anything that floats. Let's get everything in place. You probably noticed that I also added an area 2D along with an extra collision shape 2D. We're doing this for both the mushroom and the campfire. These serve as detection zones. They allow us to check when the player is nearby. So whenever the player enters one of these areas, we can trigger an action like healing, saving, or showing a message. Simple but super useful, and we'll build more on this in the next steps. Okay, let me think for a second. The spirit doesn't really need any collision zones, and honestly, we don't even need a separate scene for it right now. So let's keep things simple. We'll delete the spirit scene we just created, and instead, we'll integrate the ghost animation directly into the player scene. This way we can control it more easily and trigger the animation right when the player dies. Alright, just follow the next steps with me and we'll set it up properly. Let's go ahead and add the mushroom to the world scene. Just drag it in and place it anywhere you like. Pick a spot that feels right. Totally up to you. Next, let's head into the player script and set the spirit to invisible for now. We'll trigger that later when the player dies. As for the campfire, we'll place it in the camp scene. I personally really like this spot for our little fire. It gives the place a cozy vibe. Now, let's create a new script for the campfire. Later on, we'll use this script to handle saving the game. Make sure to save the script in the right folder so everything stays organized. We'll add a simple ready function and make the campfire visible when the scene loads. And finally, let's run it and see if everything works. Looks good so far. Alright. This next part is going to be a bit more detailed. We're going to use the mushroom script to make the mushroom interactable, meaning we can attack it and collect it afterward. This enemy is definitely a bit easier to deal with. After all, it doesn't move, but the logic is still pretty similar to how we handled enemy attacks. We want to be able to slice the mushroom when it's in range and we're facing the right direction. So once again, we'll use Area 2D signals, just like we did with the enemies. Next, we'll trigger the break animation and we'll set the duration of the final frame so it doesn't just snap back or disappear too quickly. Then we add a timer to control what happens after the animation. And with that, we're good for the first part. Now comes the fun part. We want to be able to collect the mushroom pieces, and later on, we'll even save the number of mushroom pieces you've collected. So even if the mushroom comes back when you reload the game, your collected amount will stay saved and carry over. Let's test it quickly. Yep, looks pretty good so far. Alright, let's jump back into the player script. We're going to reuse most of the logic we already created for attacking enemies. But this time, we'll adapt it for the mushroom. First up, we'll copy and adjust the variables we need. Then we bring in the function that checks the player's attack direction. In the global script, we'll set up a new variable so we can track the mushroom interaction globally too. Next, we'll go through the 4 hitboxes and connect the signals the same way we did before. This time, pointing everything toward the mushroom logic. Of course, the mushroom also needs a function so that we can use it for the signals. From here, it's mostly just copy-paste. Repeat the same process for all the signals. I'll speed things up a bit, so I'll stay quiet for now and we'll catch up again in a moment. Now let's print the status of our new function to make sure everything works as expected. Quick final check on the code. And don't forget to call the function. That one gets me every time. Alright, let's run it. And there it is, works perfectly. The output shows exactly when the mushroom can be damaged, just like we wanted. And with that, the project got a few nice visual upgrades. We improved the chase behavior and added new sprites for the collectible mushroom, the campfire, and the respawn ghost. So little by little, the game is starting to feel more polished and much more alive. In the next episode, we will keep pushing things forward. If you want to continue the journey, I will see you in episode 6. Thanks for watching and see you in the next one.